So it powers on. This is the servo. This is the grayscale. This is the photo interrupter. This is ultrasonic, and these are all motors. Yep, that's it. And this is the camera going through a hole onto the Pi board. And this is the batteries connected here. Probably not. Record on the computer. I don't know where the cloud goes. All right. Okay, so this is ss.py. This is our program that does the auto driving for part 1 of the lab. We just import the ultrasonic pin and the FC class from the library provided by the car kit. And then in the main function here, we just make an ultrasonic object, set the servo angle to 0, and then tell the car to start moving forward. And in the infinite while loop, we get the distance, and we just keep the distance within these two values as our threshold. And if it's within those threshold, we back up for like a second turn randomly for like 2 seconds, which is enough for it to make a 360 turn, and then have it start going forward in that new direction.
Okay, so for our function to make the map using the ultrasonic sensor, we use the ultrasonic sensor, we create a map, which is a NumPy array of zeros. We set the servo angle to -70, and then we start the build map process. This build map process goes every 2 degrees. It will scan and then test our current angle to see if there was a previous angle that it matched with to draw in between. Otherwise, we just draw the value up here in add point. If we do have values to add in between, then we do the mark slope method, which will handle that. In the add point method, we give it some extra buffer area with these x-1, x+1, you see. And then, yes, our map will be created with the car location at 50, 0. And yeah, okay, bye. Go for it. Go.
And then we have our other program, AAlgo, which is just our scanning code. This is all our scanning code that we explained before. This is now our AAlgo code. So I have a grid, which is a 2-dimensional array that's just a global one. We have a class node that keeps track of the row and column the node is in, the F value, G value, and H value, which is all required for A star algorithm. Also a Boolean to keep track if it's a wall or not. I also have the nodes keep track of their neighbors for the A star function, and I also have to keep track of the previous. Oh yeah, I also cited 2 links at the start of this file because I needed help implementing the A star, so the YouTube video and the Wikipedia page. Yeah. So this function makes the grid based off the MP array that we made from our scanning code, and it just makes instantiates our grid with the nodes depending on if there's like a wall or not, or if there was no wall, it would just be a normal node. And we also add the neighbors for each of these nodes. These are heuristic. This is the Manhattan heuristic. I use this one because it seemed to be the easiest and more clear, the clearest one to use, because Euclidean distance seemed to be quite like quite flawed. It had a lot of problems with it. It's just the A-star program. You just have an open set, close set, and in just a while, it's like Dijkstra's. So you keep iterating until the open set is empty, and once you are able to go to that, you go through the neighbors of the current node you're at, and you add them to the open set and change their G and F values, and you keep looping until you've visited every single node until you reach the goal node, basically. And this is the code to move our car, and it follows the path. Follows the path that's returned from A-star. And the main function that just instantiates all of our scanner code and our A-star code. And that's it. Okay, so this is the object detection for the lab one, the Raspberry Pi. We call it detect Pi. And I turn on, and that's the camera detect that Pi. Or the Raspberry Pi, you can calculate that there's a stop sign right in front of its face. And can also detect people and the bicycle. So yeah, it works. So that's a stop sign on the box, and it's gonna recognize it soon, and it's gonna do an extremely long stop. So right here, it recognizes it, so it's doing a longer stop than it usually would after it's doing the ultrasonic scanning. So as you can see, it's still staying there, and then it's gonna go on its way and ignore the stop sign. You can see the stops are way quicker now than the last one when it saw the stop sign, and it reaches its destination.